On the winter solstice in 1720, the antiquarian William Stukeley stood on the Salisbury Plain and watched the sun rise directly over a single standing stone. The alignment was precise. The light moved along a corridor formed by massive upright pillars, passing through a central horseshoe of even larger stones before illuminating the interior of the monument. Stukeley recorded the observation in his journals, noting that the positioning appeared deliberate, calculated to mark this specific moment in the solar year. 3 centuries later, that alignment still functions. Every winter solstice, the sun rises at exactly the same angle, tracked by stones that have stood in place for more than 4,000 years. The main axis of the structure points toward the midsummer sunrise and the midwinter sunset. Secondary features track the extreme positions of the moon during its 19-year cycle. These orientations are measurable, repeatable, and not accidental, but documenting what the stones mark does not explain how they came to be there. The largest blocks at Stonehenge weigh approximately 50 tons. They were quarried 30 kilometres to the north and transported across terrain that includes valleys, rivers, and gradual elevation changes. The smaller stones, known as blue stones, weigh between 2 and 5 tons each. Their origin lies in the Preseli Hills of southwestern Wales, a straight-line distance exceeding 250 kilometres. No wheels, no metal tools capable of cutting sarsen sandstone, no written language, no administrative records describing the organization of labor or the methods of transport. What remains is the structure itself, standing on an open plain with nothing around it to suggest how it was built or why it was abandoned. The construction is dated to approximately 3000 BCE for the earliest earthworks, with the stone circle completed around 2500 BCE. This places Stonehenge in the Neolithic period, before the development of bronze metallurgy in Britain, before the arrival of written language, during a time when the population of the British Isles numbered in the tens of thousands. The society that built it left no cities, no palaces, no administrative centers. They left stone arranged with precision that requires explanation. The questions surrounding Stonehenge have persisted since the first documented observations in medieval chronicles. Who built it? How were the stones moved? What purpose did it serve? And why, after centuries of continuous use, was it abandoned, left to stand silent on an empty plain with no indication of what it once meant? According to conventional history, Stonehenge was constructed in multiple phases spanning more than 1,000 years. The earliest activity at the site dates to around 3000 BCE, when Neolithic communities dug a circular ditch and bank enclosing an area approximately 100 meters in diameter. Inside this enclosure, they placed a ring of 56 pits, now known as the Aubrey Holes, after the 17th century antiquarian John Aubrey, who first documented them. Archaeological excavations have revealed that these pits once held wooden posts or stones, though their precise function is not certain. Some researchers interpret them as markers for astronomical observations. Others suggest they served ceremonial or symbolic purposes. Cremated human remains found within several of the pits indicate the site was used for burial during this early phase, though the scale is relatively small, fewer than 200 individuals over several centuries. The second major construction phase occurred around 2500 BCE. This involved the transportation and erection of the blue stones, the smaller pillars that form part of the inner arrangement. Analysis of the stone composition has traced these blocks to specific outcrops in the Preseli Hills of southwestern Wales. The distance between the quarry and Stonehenge measures approximately 250 kilometres in a straight line, though the actual transport route would have been considerably longer, following valleys, river systems, and possibly coastal waters to avoid impassable terrain. Researchers generally agree that the blue stones were moved by human effort rather than glacial action, which had been an earlier hypothesis. Evidence supporting this includes the specific selection of certain rock types from the Preseli quarries, the presence of similar stones at other Neolithic sites along the presumed transport route, and the absence of glacial deposits that would indicate ice sheet movement in the region during the relevant time period. The third and most intensive construction phase began around 2400 BCE with the arrival of the sarsen stones. These massive blocks form the outer ring, and the trilithons, the iconic paired uprights capped by horizontal lintels. The sarsens weigh between 25 and 50 tons each, and were quarried from the Marlborough Downs, approximately 30 kilometres north of Stonehenge. Unlike the bluestones, the sarsens are local stone, but their size and the precision required to shape and position them represent a significant escalation in technical demands. The sarsen circle originally consisted of 30 upright stones, each standing approximately 4 meters tall, with a continuous ring of lintels locked in place using mortise and tenon joints. Inside this circle, 5 trilithons were arranged in a horseshoe pattern, with the largest stones positioned at the center, reaching heights exceeding 7 meters, including their lintels. The shaping of these stones involved removing material from rough quarry blocks to create flat surfaces, squared edges, and the joint features necessary for assembly. Conventional explanations attribute the construction to organized Neolithic communities working under a shared religious or social framework. The labor force is estimated to have numbered in the hundreds or thousands, depending on the construction phase and the specific tasks being performed. Food and resources to sustain this workforce would have required surplus agricultural production, suggesting a level of social complexity and coordination not typically associated with small-scale farming communities. Archaeologists currently believe Stonehenge functioned primarily as a ceremonial and ritual site, possibly serving as a gathering place for regional populations during specific times of the year. The alignment to solar and lunar events suggests it played a role in tracking seasonal cycles, which would have been important for agricultural planning. The presence of cremated remains indicates the site held significance for funerary practices, though whether it was a cemetery for an elite class or a broader communal burial ground is still debated. This framework, Neolithic construction, astronomical orientation, ceremonial function, has guided scholarly interpretation for more than a century. It accounts for most of the physical evidence and fits within what is known about other European megalithic traditions. But the framework depends on assumptions about labor organization, transport methods, and construction techniques that have not been fully demonstrated at the scale required by Stonehenge. The technical challenges of constructing Stonehenge begin with the quarrying. The sarsen stones are blocks of silicified sandstone, a material harder than granite and difficult to shape using stone tools. Neolithic builders had access to flint, antler, and wood. They did not have bronze, which would not arrive in Britain for another 500 years after the Sarsen phase. They did not have iron, which would not become available for more than a millennium. Experimental archaeology has demonstrated that sarsen can be shaped using sarsen hammerstones, smaller pieces of the same material used as pounding tools. The process is slow. Shaping a single sarsen block to the dimensions required for a Stonehenge upright, with flat surfaces and squared edges, would take months of sustained effort by multiple workers. The stones also show evidence of deliberate smoothing on their visible faces, while the buried portions remain rough. This selective finishing indicates an understanding of where precision mattered and where effort could be conserved. Once shaped, the stones needed to be moved. The standard explanation proposes wooden sledges and rollers. A sledge distributes weight across a larger surface area, reducing ground pressure. Rollers placed beneath the sledge reduce friction, allowing the load to be pulled forward incrementally. Large teams of workers, potentially numbering in the hundreds, would provide the pulling force using ropes made from plant fibers. This method has been tested on smaller scales. Modern researchers have successfully moved multi-ton stones using sledges and rollers, demonstrating that the basic principle works. But scaling the technique to 50 tons introduces complications. The rollers themselves would need to be massive, thick wooden cylinders capable of bearing extreme loads without crushing. The ropes would need to be correspondingly strong, woven from materials like flax or hemp, in quantities that would require significant agricultural output. And the coordination of hundreds of workers pulling in unison would demand a level of organization that leaves no archaeological trace. The route from the Marlborough Downs to Stonehenge crosses the River Avon and includes gradual elevation changes. Moving a 50-ton load across a river requires either a ford with stable footing or a bridge capable of supporting the weight. No evidence of such infrastructure has been found, though temporary wooden structures would not necessarily survive in the archaeological record. The elevation changes would require additional effort, either more workers or a longer, more gradual route that minimized steep inclines. Transporting the bluestones from Wales presents a separate set of challenges. The distance is 10 times greater than the Sarsen transport. The route crosses multiple river valleys and, in some proposed scenarios, includes a coastal segment where stones would be loaded onto rafts or boats. Moving a 2-ton stone by water is feasible, but it requires vessels stable enough to handle the load without capsizing and navigation skills sufficient to manage currents, tides, and weather conditions. Some researchers have suggested the bluestones were moved overland entirely, following river valleys and ridgelines to minimize difficult terrain. This would make the journey longer but avoid the risks of water transport. Either way, the effort required is substantial, and the motivation for selecting stones from such a distant location is not clear. Local alternatives existed. The choice to bring bluestones from Wales suggests they held specific significance, though what that significance was remains uncertain. Once the stones arrived at the site, they needed to be erected. The upright Sarsens are buried approximately 1/4 of their length into the ground. Digging a pit deep enough to accommodate a 50-ton stone using antler picks and wooden shovels is labor-intensive but achievable. The challenge is lowering the stone into the pit without fracturing it and then raising it to vertical without mechanical assistance. The standard explanation involves digging a ramped pit with one side sloped, dragging the stone to the edge, tipping it into the pit so that it slides down the ramp, and then using ropes and wooden levers to pull the stone upright. Packing stones and earth around the base would stabilize it once vertical. This method has been demonstrated in small-scale experiments, but again, scaling to 50 tons introduces uncertainty. The forces involved are immense. A stone tipping at the wrong angle could shatter. Workers attempting to control the descent with ropes could lose control. The margin for error is narrow. The lintels present an additional problem. These horizontal stones weigh approximately 10 tons each and sit on top of the uprights, secured by mortise and tenon joints. Lifting a 10-ton stone 4 meters into the air requires either a ramp system or a platform built up around the uprights. Both methods are plausible, but neither leaves a clear archaeological signature. Wooden ramps and platforms would decay, and the volume of earth required for ramps would be substantial, possibly more earth than the volume of the stones being lifted. No trace of such earthworks has been identified at Stonehenge. What remains uncertain is not whether the construction was possible, but how it was accomplished using the tools and labor available at the time. The proposed methods work in principle. They have not been demonstrated at full scale under controlled conditions. The gap between what experimental archaeology has shown to be feasible and what would have been required to build Stonehenge leaves room for doubt. The dating of Stonehenge has been refined over decades through radiocarbon analysis of organic material found in association with the stones. These dates place the major construction phases between 3000 and 2400 BCE, with some refinement of the internal structures continuing into the early Bronze Age. Not all researchers agree on the interpretation of these dates or the sequence of construction. One area of disagreement centers on the bluestones. Some archaeologists argue that the bluestones were erected before the Sarsen Circle based on the positioning of bluestone fragments found beneath Sarsen stones. Others interpret the evidence differently, suggesting the bluestones were moved and rearranged multiple times during different construction phases, which would account for their current irregular placement. The sequence matters because it affects our understanding of how the site evolved and what priorities guided the builders. Another point of tension involves the purpose of the Aubrey holes. These pits form a precise circle and are evenly spaced, suggesting careful planning. Some researchers propose they functioned as an astronomical calculator, with the 56 holes corresponding to cycles of lunar eclipses. Others argue the holes simply held posts or stones that marked the perimeter of the earliest monument, with no astronomical significance beyond the general solar alignment of the site. The evidence does not definitively support either interpretation. Methodological disagreements also exist regarding the transport of the bluestones. Proponents of the overland route cite the presence of bluestone fragments at sites along the proposed path, suggesting the stones were moved incrementally with rest stops. Proponents of a combined land and water route argue that water transport would have been more efficient and that coastal navigation was well within the capabilities of Neolithic communities familiar with the region. Both explanations are plausible. Neither can be confirmed without more direct evidence of the route itself. The function of Stonehenge as a whole continues to generate differing views. The astronomical alignments are undeniable, but whether they served practical purposes, such as marking the solstices for agricultural calendars, or held primarily symbolic or religious significance, is a matter of interpretation. Some researchers emphasize the cremation burials, arguing that Stonehenge was fundamentally a funerary monument. Others focus on the scale and visibility of the structure, suggesting it functioned as a gathering place for dispersed communities who came together periodically for ceremonies. Recent excavations in the surrounding landscape have revealed additional complexities. The discovery of Durrington Walls, a large Neolithic settlement located 3 kilometres from Stonehenge, suggests that significant populations were present during the construction phases. Evidence of feasting, including animal bones and pottery, indicates that large groups gathered at Durrington Walls, possibly in connection with activities at Stonehenge. Whether Durrington Walls was a workers' village, a pilgrimage destination, or something else is still being determined. These scholarly tensions are not evidence of suppression or disagreement about fundamental facts. They reflect the limitations of the archaeological record and the difficulty of reconstructing intentions from material evidence alone. Stones can be dated, alignments can be measured, but the reasons people chose to invest enormous effort in their construction are not written in the stones themselves. In 2013, archaeologists using ground-penetrating radar identified a series of large pits surrounding Stonehenge in a circle nearly 2 kilometres in diameter. The pits are evenly spaced and appear to have been deliberately dug and then refilled. Initial analysis suggests they may have held posts or stones, forming a boundary far larger than the visible monument. This means the landscape around Stonehenge was modified on a scale significantly greater than previously understood. The discovery reframes what we thought we understood about the site. Stonehenge was not an isolated monument. It was the center of a much larger constructed landscape, with features extending across kilometers. The labor required to dig and maintain such a boundary would have been considerable, suggesting that the communities involved in Stonehenge's construction had resources and organizational capacity exceeding earlier estimates. Further investigation of the Preseli Hills in Wales has revealed that the bluestone quarries were not simple extraction sites. Evidence of stoneworking, including hammerstones and stone debris, indicates that the bluestones were shaped before transport. Some of the stones show signs of having been part of earlier structures in Wales before being dismantled and moved to Stonehenge. This raises the possibility that the bluestones carried symbolic or historical significance beyond their material properties. If the bluestones were taken from pre-existing monuments, their transport to Stonehenge may have been a deliberate act of incorporation, bringing stones that already held meaning and integrating them into a new, larger structure. This would explain the effort involved in moving them such a great distance when local alternatives existed. It would also suggest that Stonehenge was not simply a new construction, but a consolidation of earlier traditions. Analysis of the sarsen stones has revealed that they were selected for specific acoustic properties. When struck, certain sarsens produce clear, ringing tones. Researchers testing this phenomenon have found that the stones with the most resonant acoustic properties were preferentially placed in prominent positions within the monument. Whether this was intentional or coincidental is debated, but the pattern is consistent enough to warrant attention. The acoustic properties could have served a functional purpose during ceremonies, allowing sound to carry across the site. Alternatively, they may have held symbolic significance, linking sound to the spiritual or ritual activities conducted at Stonehenge. Either interpretation suggests that the builders considered factors beyond structural stability and astronomical alignment when selecting and positioning stones. Geometric analysis of the monument has identified mathematical relationships between the spacing of the stones, the dimensions of the circle, and the proportions of the trilithons. Some of these relationships correspond to ratios found in later architectural traditions, including classical Greek temples. Whether this reflects intentional mathematical design or coincidental convergence is uncertain. Ancient builders working with practical constraints, such as the need to space stones evenly or balance loads, might naturally arrive at proportions that appear mathematically significant without consciously calculating them. Astronomical alignments extend beyond the well-known solstice orientations. Detailed surveys have identified secondary alignments corresponding to the extreme positions of the Moon during its 19-year cycle, known as the lunar standstill. These alignments are subtle and would require sustained observation over generations to identify and incorporate into the monument's design. The presence of these features suggests that whoever designed Stonehenge possessed detailed astronomical knowledge accumulated over long periods. The implication is that Stonehenge was not built from a single plan conceived at the beginning of construction. It evolved over centuries, with successive generations adding, modifying, and refining the structure based on accumulated knowledge. This makes Stonehenge a repository of information, a physical archive of astronomical observations encoded in stone. Comparisons with other megalithic sites in Britain and Europe reveal patterns that complicate the narrative of independent development. The stone circles at Avebury, located 30 kilometres north of Stonehenge, share similar construction techniques and astronomical orientations. The Ring of Brodgar in the Orkney Islands, built around the same time as Stonehenge, uses comparable design principles despite being located more than 800 kilometres to the north. These similarities suggest a shared cultural framework or exchange of knowledge across regions. Further afield, megalithic structures in Brittany, Malta, and the Iberian Peninsula show architectural features that parallel those at Stonehenge: stone circles, chambered tombs, solar alignments. The geographic distribution of these sites spans thousands of kilometers, raising questions about how such consistency emerged. Were these traditions developed independently by communities solving similar problems, or did they reflect connections, through migration, trade, or shared ancestry, that linked distant populations? The scale of these connections, if they existed, would require rethinking assumptions about Neolithic mobility and communication. Conventional models emphasize small, localized communities with limited long-distance interaction. The archaeological evidence increasingly suggests otherwise. Exotic materials found at Stonehenge, including amber from the Baltic region and gold from Ireland, indicate that trade networks spanned the European continent during the Neolithic period. Stonehenge is not unique. Across the British Isles and continental Europe, hundreds of megalithic monuments were constructed during the Neolithic period, many predating Stonehenge by centuries. The chambered tombs of Newgrange in Ireland, built around 3200 BCE, feature a passage aligned to the winter solstice sunrise. The complex at Carnac in Brittany contains thousands of standing stones, arranged in rows extending for kilometers. These structures required labor, planning, and coordination comparable to Stonehenge. The recurrence of solar and lunar alignments across these sites suggests that astronomical observation was a widespread practice among Neolithic communities. Whether this knowledge developed independently at each location or spread through cultural exchange is difficult to determine. The consistency of the alignments, however, indicates that the techniques for tracking celestial events were well established and transmitted across generations. Beyond Europe, megalithic traditions appear in other parts of the world with no apparent connection to the European Neolithic. The stone circles of Senegambia in West Africa date to between 300 BCE and 1600 CE, much later than Stonehenge, but use similar construction principles. The arrangement of monoliths at Göbekli Tepe in Turkey, dated to around 9600 BCE, predates Stonehenge by more than 6,000 years, yet shares design features, circular arrangements, astronomical alignments, and symbolic carvings on the stones. These parallels do not necessarily indicate direct cultural contact. Different societies facing similar challenges, marking seasonal cycles, organizing communal labor, expressing shared beliefs, may independently develop similar solutions. But the specific convergence of features, stone circles, solar alignments, burial associations, occurs often enough to warrant attention. Discoveries once dismissed as anomalous have later been validated. Ötzi the Iceman, a naturally mummified body found in the Alps in 1991, was initially controversial because his level of equipment and clothing sophistication did not match assumptions about Neolithic capabilities. Subsequent analysis confirmed he lived around 3300 BCE and carried copper tools, processed leather, and evidence of medical treatment. The discovery forced revisions to estimates of Neolithic technology and social complexity. Similarly, the Nebra sky disk, a bronze artifact from Germany dated to around 1600 BCE, was initially doubted as too advanced for the Bronze Age. It depicts the sun, moon, and stars in a configuration that corresponds to specific astronomical events. Once authenticated, it became one of the oldest known portable astronomical instruments, demonstrating that Bronze Age communities possessed detailed celestial knowledge encoded in physical form. These examples demonstrate that assumptions about the capabilities of ancient societies are subject to revision as new evidence emerges. What appears anomalous within an existing framework may simply reflect gaps in the framework itself. The question is whether Stonehenge fits within our current understanding of Neolithic capabilities, or whether it represents an outlier that requires rethinking those capabilities. At the center of the Stonehenge mystery is a question that remains unanswered. How did Neolithic communities, working with stone tools and organic materials, organize the labor and resources necessary to construct a monument of this scale? This is not a question about the technical feasibility of individual tasks. Experimental archaeology has shown that stones can be shaped, transported, and erected using Neolithic tools. The question is about the system that made sustained, coordinated effort possible over generations. Building Stonehenge required not only workers, but also surplus food to feed them, materials to make tools, and social structures capable of directing labor toward a project that offered no immediate survival advantage. What we can measure is the monument itself. We can calculate the weight of the stones, the distances they were moved, the precision of their placement. We can date the construction phases and identify the sources of the materials. We can document the astronomical alignments and analyze the geometric relationships encoded in the design. What we cannot reconstruct is the organizational framework that sustained the project. How were decisions made? Who directed the work? How was labor recruited or compelled? What motivated communities to invest years of effort in construction rather than subsistence? The stones do not answer these questions. They are the result of a process, not a description of it. The absence of written records means we are reconstructing this framework from material evidence alone. We find tools, we find bones, we find post holes and stone settings. We do not find organizational charts or project plans. The inference from evidence to explanation requires assumptions about how Neolithic societies functioned, and those assumptions are based on comparisons to other pre-literate societies and extrapolations from limited data. The explanations we have are plausible. They account for most of the observed evidence, but plausibility is not certainty. The margin between what is proven and what is assumed remains wide. And within that margin, the question persists. How was Stonehenge built, not in principle, but in practice? The stones are still there, standing on the Salisbury Plain exactly as they have for more than 4,000 years. The outer circle is incomplete now. Some stones have fallen, others were removed in later centuries, but the basic configuration remains intact. The trilithons still frame the central space. The alignment to the solstice still functions. Every summer and winter, crowds gather at Stonehenge to watch the sun rise or set through the stones. The event is treated as a spectacle, a connection to ancient tradition, a moment of wonder. But the people who built Stonehenge are not there. Their names are not recorded. Their language is not preserved. The reasons they chose to build this monument, the beliefs that motivated them, the meanings they attached to the alignments, All of this is lost. What remains is the structure, and the structure does not explain itself. It marks the solstices, it tracks the moon, it stands in the landscape as a permanent feature, visible for kilometers in every direction. But it does not tell us why it was important to mark these events in stone, or what those markers signified to the people who erected them. Conventional explanations frame Stonehenge as a ceremonial site, a calendar, a cemetery, a gathering place. These interpretations are based on evidence, the cremated remains, the astronomical alignments, the scale of construction. But they are also based on assumptions about what communities 4,000 years ago valued, believed, and were capable of achieving. The assumptions may be correct, they may be incomplete. The evidence supports the framework, but it does not prove it. And the difference between supported and proven is the space where uncertainty lives. Stonehenge stands as a reminder that the past is not as accessible as it appears. We can measure, we can date, we can reconstruct, but reconstruction is not the same as recovery. The monument is physical, the meaning is not, and without the meaning, the stones remain what they have always been since the last person who understood them walked away. Silent, aligned, waiting for questions that may never have answers.